Well, today we will do some application, one application which has two parts of midpoint theorem, which we did in the last class. And this problem, the statement of this problem is on the screen. Please pause and write down. But I say what it says. It says that before I go into the problem, let me welcome those who are new to Have Fun and Learn with Javidatta. Welcome. And if you like the video, of course you will subscribe, share and comment. So we have got P, Q, R and S. P is the midpoint of AB. Q is the midpoint of BC. R is the midpoint of BC. And S is the midpoint of AD. Right? Now we have to prove that the figure, the quadrilateral PQRS, is a rhombus. So in my previous classes, some classes ago, please look at the description box, we discussed about special types of parallelograms. In that, we discussed the properties of rectangles as well as properties of rhombus. Now, as a refresher, please remember for a rectangle, okay, before going into it, let us join the diagonals. It looks like this now. Now, let us find out what all the properties we are going to apply here to prove that PQRS is a rhombus. Rectangle, for a rectangle, diagonals are equal, right? So we can write AC is equal to BD, right? To prove PQ is equal to QR is equal to RS is equal to SP. This we have to prove. Right? Now this doesn't disprove the fact that it could be a square also. Why it is not a square? That also we will argue. Now see, in triangle ABC, P and Q are midpoints of AB and BC respectively. Right? Now by midpoint theorem, we can write PQ is equal to half of AC and PQ is parallel to AC. Right? Number. This is number. Similarly, if we consider triangle BCD, we can say R and Q are the midpoints of DC and BC respectively. Right? So by midpoint theorem again, what we can write? RQ is half of PD, right? And RQ is parallel to BD, right? Similarly, we can prove SP is equal to half of BD and SR equal to half of AC. Right? So look at this. But for a rectangle, the diagonals are equal, we said. Therefore, PQ is equal to QR, and that is equal to RS, and that is equal to SP. Now we are sure that square, but why not a square? See, for this, these are PQ, this RP is the diagonal, and SQ is the diagonal of the other one. So the diagonals are not equal. AB, PQ, PQ, RS is a rhombus. Reason? Because the diagonals are unequal. So that is why it is not a square, right? So this is what we had as a good application of midpoint theorem, right? Now we will next go on to converse of midpoint theorem, right? So let us move on to converse of midpoint theorem. Welcome those who are new to this channel, HaveFun&Learn with JP Datta. If you're interested in my previous videos, please look at the description box. It will be all the links of the videos that we have done till today, right? Now, the optics is something like that. Meaning thereby, in midpoint theorem we said that D and E were midpoints. And if you join D and E, it will be parallel to BC, parallel to the third side, and half the third side. Here, the scenario is converse. It is said that ABC is a triangle, and D is the midpoint of side AB, and we draw a line through D parallel to BC, intersecting the other side at E. It is also said that DE is half of BC, right? Now, in order to do that, what we will do, we'll extend DE to the right, and we'll draw a line parallel to AB from C to that line intersecting it at F. If we do that, it will look like this. Now what we have done is, we have extended DE to F, and then we have drawn a line parallel to AB, CF. Right? Now we have to prove that this is equal to this, that is AE is equal to EC. So let us write a construction. The construction part. What will be that? Extend DE to F, draw CF, parallel to AB. This is our construction, correct? Now, if we do that, we can say that now what are known to us. See, we know AD is equal to DB. That is number one. We also know by construction AB is parallel to CF. This is by construction. Okay. Now, if we take these two triangles, this triangle and this triangle, let us see what we get. In triangle ADE and triangle CFE, number one, angle AED is equal to angle CEF. These two angles. Why? Vertically opposite. Number one. Number two, we can write angle ADE. We have these two lines are parallel, so this angle will be equal to this angle, right? So angle DAE is equal to angle FCE. Why? Alternate angles. Right? Since DBCF is a parallelogram, by construction, DB is equal to CF, but AD is equal to DB. Therefore, AD is equal to CF. Right? Get that correct. So number 3 we have AD is equal to CF. Okay. Therefore, triangle ADE is congruent to triangle CFE. Right? Let's check. AD is equal to CF, DE is equal to EF, and AE is equal to CE. And it's correct, right? So we can write now. Now we can write now. We can conclude AE is equal to EC. Why? Pi CP CT. Well, that means E is the midpoint of AC. So that is what was all about the converse of midpoint theorem. The statement of the converse of midpoint theorem is on the screen. But have a look at it and write down and check whether you got it correct or not. Right? So that will be all for today. Next class, let us see what we do. We'll find out what we'll do, and before we meet again, we'll say goodbye. But I think it's also important to subscribe to my channel. So please subscribe, share, and comment on my videos, and give a thumbs up if you like it. Right? So see you in the next.